Hello, this is the section 2.4 lesson. In this section we're going to introduce yet another type of distribution, one that we call the Poisson distribution. So first let's define the Poisson distribution. A random variable x has a Poisson distribution if its PMF is given by this. So f of x is, by definition, the probability that x equals x, and that in this case is equal to lambda to the x power divided by x factorial times e to the negative lambda, where x can take values 0, 1, 2, 3, so on and so forth. And then this number lambda is some positive constant. Okay? And so that's all there is to this PMF. There's no combinations or permutations or anything like that. It's just exponents and factorials. Now, the next question is, what can we do with a Poisson distribution? Well, Poisson distribution has a lot of different applications. One common type of application is that it describes the number of occurrences over a randomly selected interval. Now, interval could take on a lot of different meanings. It could be an interval of time, it could be an interval of length, it could be an interval of area, it could be an interval of volume. And then an occurrence is just something that we're interested in, and we'll illustrate this with our next example. Now, the parameter lambda is the quote-unquote average number of occurrences per interval. Okay? And so to illustrate this, let's look at this example. So suppose a 1,000 square foot lawn contains exactly 3,000 dandelions. Find the probability that a randomly selected 1 square foot section of lawn contains exactly 5 dandelions. Okay. Now, at first glance, this may look kind of like a hypergeometric distribution or a binomial distribution, but notice that we're not selecting items without replacement. In fact, we're not selecting items at all. We're simply choosing a 1 square foot section of lawn. So it's not a hypergeometric distribution. And nor are we repeating some experiment over and over again. We're just choosing 1 square foot section. So it's not a binomial distribution either. This is going to be a Poisson distribution. In this case, an occurrence is a dandelion, because that's what we're interested in. And then an interval, in this case, is a 1 square foot section of lawn. And so then our random variable x is the number of dandelions in a 1 square foot section. And we're going to assume that x has a Poisson distribution. This is a reasonable assumption based on the description of the scenario. And so now, in order to use the Poisson distribution, we need to know the value of our parameter lambda. Well, lambda in a scenario like this is the average number of occurrences per interval. So we're going to take the number of occurrences, which in this case is our 3,000 dandelions, and divide it by the total number of intervals, which is 1,000 square feet. And so we get our value of lambda here, 3 dandelions per square foot. Okay. And now we just need to plug things into our PMF. We want to know the probability of exactly 5 dandelions. And so we have here lambda to the 5th power divided by 5 factorial e to the negative lambda. And then we do that arithmetic and we get 0.101. So that's all there is to using the Poisson distribution. What this number means in a practical sense is that about 10% of all 1 square foot sections of our lawn are going to contain exactly 5 dandelions.